this video, Minabe Mitsumi illustrates a method for positive air pressure device manufacturers to reduce sensor costs. According to the Sleep Foundation, obstructive sleep apnea is estimated to affect 10 to 30% of adults in the United States. Positive airway pressure is a routine therapy used to manage obstructive sleep apnea. High-end PAP devices control pressure and airflow to ensure that prescribed conditions are maintained. Sensors are critical to ensure that PAP devices operate within the defined parameters. In a typical setup, a gauge pressure sensor is used to monitor system pressure, while a differential pressure sensor measures airflow. A differential pressure sensor calculates airflow by correlating the drop in pressure across a flow restrictor with the rate of airflow. Both sensors are installed onto a PCB, and a custom gasket is inserted over the sensor ports, which seals the air pathway. As the blower generates airflow and pressure, a pressure drop occurs when the air is constrained by the flow restrictor, and upstream pressure becomes greater than downstream pressure. The pressure drop value is used to calculate flow rate within the PAP device. The main difference between a gauge pressure sensor and a differential pressure sensor is the reference pressure value. A gauge pressure sensor has an external vent that uses atmospheric pressure as a reference point, while DP sensors measure the difference between 2 points using high and low pressure ports. DP sensors are more complex, which results in higher costs and a larger footprint. By modifying the custom gasket, PAP manufacturers could substitute a more cost-effective gauge pressure sensor within the same pressure range. Instead of sealing the gasket to the low-pressure port of a DP sensor, the gasket is designed to create a seal around the gauge pressure vent opening. In this recommended cost-savings design, 2 gauge pressure sensors are installed on the PCB of a PAP device. One has a standard 40 centimeter of water rating, while the second is rated for ultra-low pressure of less than 2.5 centimeters of water. The custom gasket seals the port on each sensor to the same pressure aperture located upstream of the flow restrictor. The standard sensor is vented to the atmosphere, while the ultra-low pressure sensor vent is sealed onto a downstream aperture. When the blower is turned on, the 2 gauge pressure sensors operate in the same manner as a traditional setup. In summary, using a gauge pressure sensor in place of a differential pressure sensor can help reduce system costs, since gauge pressure sensors are typically less expensive. Minabe Mitsumi offers the standard MMR920C04 sensor for upstream pressure measurement, and we are currently developing the MMR921C25, a new ultra-low pressure sensor ideal for PAP downstream monitoring.